of that mail even to your HOD. So let everything, even let your HOD also know what is that you're mailing to me. Okay. So we thereafter start, and it was surprising or shocking that not all of you were present for the session at 12 o'clock. Quite a lot of you were missing. See, all this shows your interest in this. How interested you are. It is and I had told the three guys who were present in the morning today that tomorrow, when to submit the solution by 6 in the evening, and thereafter we will have a session maybe around 8:30, 9 o'clock. Along with you, there will be students even from the other colleges, from a very lead university in Pune. The students would be there. There would be students from Gujarat also, and few other places also will be part of your team to do this internship. So please understand, it is not that I'm falling short of people. In this country, in India, there is absolutely no dearth of getting people to do anything. No problem. Please, all those of you who are not able to make up in the morning today, please ask your friends as to what was conveyed, so that you are also able to share your part of your story. It's absolutely fine, no problem. But 6 o'clock, I mean, has to be 6 o'clock in the evening tomorrow. So I hope my Jupyter notebook is clear to you. I mean, is visible to you. Is it? Please confirm it
Yes,
to
sir.
me.
No, no,
Okay. So
no, no.
see,
Yeah. Now it's there.
okay, if you remember yesterday, we had written a smart contract, a small little smart contract. Today, what we will do, we will jump little more deep into the smart contract, see what those things are there which is involved in making a smart contract. But before we even take off, can somebody confirm if the smart contract which was written yesterday, is it clear to you? Did you get a hold of how do you write it? Anybody? All those who were present for the session yesterday, did you come to know how do you write a smart contract? Today we will see more in depth of this, and I shall request you, please keep interacting, otherwise there is no way I'll come to know whether you are there or not. Okay, the most important thing in a smart contract is there are blocks, and blocks are nothing but simple Python dictionaries. And can somebody tell me what all does a block in a blockchain consist of? Make an attempt, no problem. Any block in a blockchain, what kind of information does it consist of? Tell me, anybody, make an attempt, not an issue.
It
At the max, you may
contains
go
the
wrong.
data, sir.
What data?
The data to be stored that we are trying to store in the block. That data.
What else?
Um,
Sir, it could be the transaction data.
No. See, any block consists of few little information within a block. Please remember it. The first is it consists of index of the block. All these are dictionary elements. Then it consists of the timestamp. Then it consists of data. This data comprises of who is the sender, who is the recipient, and what kind of data it is. Apart from all this, it even consists of hash, a big hash key, and it consists of previous hash. That means any block in the blockchain consists of index, it consists of timestamp, it consists of data, which comprises of who is the sender, who is the receiver, and what kind of data is it. Apart from this, it even consists of hash and previous hash. These are all the information that is within a block. Please have it very, very clear in your mind, because 99.99% any interview for any kind of a job in blockchain you go, for sure this is a question which is asked, basically to understand if your fundamentals are very, very clear. And each block has a preceding basic structure. But what we will do, we will stick to this. Every block has got a hash, and it has got the address of previous hash. And please understand, the idea of a blockchain shouldn't be like, we can say that each block contains within itself the hash of the previous block, forming a chain. So every block has got the hash of the previous block, forming a chain. So each of this form a blockchain. Now, when you write a simple blockchain, what does it consist of? A very, very simple blockchain, maybe a simple, you can say, a blueprint of a blockchain. Definitely, when you write a blockchain, it has to be defined by a class. I'll say the class of blockchain of the object. Make this conditional. Then I have to define the self block. So I say define underscore underscore init underscore underscore self. And then I say this also I have to make this conditional. Then I say this initial block is an empty block. So I say self dot chain. This is nothing but an empty block. After this, what I do, I keep adding blocks to the exist this mother block or the initial block. So to add a new block, let me call it as a new block. I'll say new block of this self. I want to add a new block to the self. The first block which I've created is called self. I want to add a new block to the self. Then I write a few statements, whatever it is, and in the end I say pass. So this way, this is the blueprint of how do you generate a block. Now, now when you keep adding blocks, please understand. And anybody having any doubt, anytime you can stop me and ask me whenever you want, please. Now, when your blockchain is instantiated, you will need to send it with a Genesis block. That is a block with no predecessor and an index of 0. That means this first block is the Genesis block because there is no block before this, no predecessor. And this has got an index value of 0. And it is a special case of a block and is almost always hard coded into the software. And in Bitcoin, the Genesis block was created by Satoshi Nakamoto, and it was famously contained, and this famously contained the text in hexadecimal form, a front page, and this formed a front page of the article which was written somewhere in 2009. So when you create a simple blockchain, what happens? Let's say we once again will create a blockchain, but slightly different from what we created yesterday. When this is a JSON. Then I have to import date time and SHA-256. So I say from uh, date time, I shall import date time. And then I shall import SHA-256. Where is SHA-256? From hashlib. I shall import SHA-256. After this, I start creating my block. That is, I start with the Genesis block. First, I create the Genesis block, then I keep adding block by block to the Genesis block. So I say class, let me call it blockchain. Of this, let me say of object. Make this conditional. Then as we did earlier, I'll say define underscore underscore init underscore underscore of self. And initially, since the block does not have any element, I'll say self dot chain is an empty block. Then also I would say it will have no pending transactions since it is the first block. So I say self dot pending underscore transactions is an empty block. Now, what we do, since this is the Genesis block, I will print it out that we are creating a Genesis block. So I'll say print creating Genesis block. Then now what I say self dot new underscore block this. Now what we do, we keep adding new block and block on and on and on. But one way of creating a blockchain is straight away what I'll define my last block. So I'll say define, and in between the Genesis block and the last block, I keep adding blocks. Anyway, how you want, it is up to the programmer. So I said define the last block of this self which we have created. Now this will return the last block in the chain if at all there are blocks. So what I need to say, I say return self dot chain of -1. And here I would say if self dot chain else none. Now what I do, this will help me define the last block. Now what I'll do, I'll keep adding one by one new blocks to this. So to add a new block, what do? I create once again a function. Let me call it new block. I say new block of this self and previous hash. This I would say with previous hashes none. Make this conditional. Then I say my block. We know the block is a dictionary value which contains the index, timestamp, add transactions, and previous hash. So I'll say the first element I specify my index, which will be nothing but the length of self dot chain. Then I also say my uh, timestamp, which is nothing but my daytime dot. I say it is UTC now. UTC now, the universal time I'm taking. UTC now dot is O format. And then I would say what are my transactions? Transactions which I shall say self dot pending underscore transactions. And lastly I have to define what is my previous hash. So I say my previous hash, this is nothing but my previous hash. So my previous hash is previous hash. I give a question mark. I close this my dictionary element. Now I need to get the hash of this block and add it to the block. That is what I need to do. I need to get the hash of this block uh, and add it to this block. So for which what I'll do, I'll say block underscore hash is self dot hash of block. And then I will say my block of hash is nothing but block underscore hash. Now, after getting the hash of this block and adding to the block, what I need to do, I need to reset. I need to reset the list of pending transactions. If at all there are any kind of pending transaction. So, in order to reset the list of pending transaction, what I shall do, I shall say self dot pending underscore transactions, and I need to add the block to the chain. So I say self dot chain dot append. I need to add the block. I'm appending the block. So then what I'll do, I'll just print it out that the created block is whichever block. I'll use a F string. Tell me one thing, when you learn Python, have you learned about this F string? Why is F string used? Can somebody tell me?
Format, sir, for formatting.
Yes, okay. So I'll say created block, and I shall place a placeholder over here. So I say block of index, and I close this, give another inverted commas, and close it. Then finally, what I need to do, I need to return the block. Now, what I need to do, I need to do a static check on this. Basically, we have to ensure that the dictionary is sorted, or definitely you will get inconsistent hashes. So, in order to do that, what do I need to do? I need to once again define hash of block. Then this basically we are doing to ensure the dictionary is sorted. Otherwise we are definitely going to get inconsistent hashes. So I say block underscore string is nothing but json dot dumps of block, and I say sort keys. I set the sort keys as true. and this I'm definitely going to encode it. So I said dot encode, and then I need to return SHA-256 of block underscore string, and then let me say hex digest. So this should complete my program. So when let's execute this and see. Okay, else none. Okay, there is a error over here. So with the first one which we have written, so return self dot chain of this -1 if self dot chain else.
So in starting like 1, 2, 3, 4, 5, 6, fifth or sixth line, sir, self dot chain spelling.
So chain is correct. CHAIN I have written.
No, sir, here 1, 2, 3, 4, 5, sixth line when we
Oh,
were
okay,
declaring the.
okay.
CHCAIN is there, sir.
Okay, but it points out the error in some other line. It points out the error in this line. Uh, Once and oh, this is not is. This is if self dot chain else none. Correct, no problem. We have been able to execute our simple block. So what did we do by this? We have created a simple blockchain for this. We have created a very simple blockchain for this. Now, another very important thing, if you remember what we had done yesterday, and in the past we have been very frequently speaking of, is the proof of work. Can you tell me what do you mean by this proof of work in regard to blockchain?
Hello.
Anybody? What is this proof of work in blockchain?
Yeah. Can you hear me? Sure.
Tell me, please, help me out by what is proof of work in blockchain? Okay. Before even you telling me proof of work, since you guys have learned machine learning in which semester of your engineering?
Machine learning.
Tell me, please, which semester did you have machine learning as a subject?
Sir, now we are having an 8th semester machine learning.
Eighth semester. That is too late. Is it machine learning or are you learning on scalable machine learning
No,
technique?
it is machine learning.
Oh, that is just the algorithms. See, those algorithms were probably useful when probably Gandhiji was alive, because now it has become a history. You need to be learning on scalable machine learning, that is on AutoML, Amazon SageMaker, all these wonderful techniques. In fact, machine learning has gone
Yeah,
much
you
beyond
start.
that, and which we will be using for our internship. Don't worry, even if you don't know this, all those you are with me for your internship,
What are
definitely I shall convey it to you on the question of teapot. Have you heard of this? What is teapot? TPOT. Tell me, please. Have you heard of this TPOT? It's a wonderful machine learning technique. It's a tree-based pipeline optimization tool, which is for automating machine learning. It's a wonderful and it's a really good technique. It's an automated machine learning technique in using Python. So you should, if at all, since you are at the verge of completing your engineering, if you need to compete in this world, you should be really crewed up with this scalable machine learning techniques, that is AutoML, Amazon SageMaker, H2O, or and you should be well conversant with TPOT. Don't worry, since you've got 2, 3, 4 months more
Balaji
left for
doesn't
your
start with this.
engineering to get over.
So
Please
let
do
me
one
get you
thing:
the flow again.
be involved or get involved with this internship. If at all you don't know,
Just
don't
ignore
worry,
all
I'll
the
convey
keys
it to you.
thing and everything.
How
What
do
you have to
you
do is once in the
how do you use this and what are these things? I shall help you out.
training
Don't
notes,
worry.
okay?
Okay,
Same way you
so
have to
what
run it
we will do,
manually.
we were
Add some
speaking
data
on
in the
this.
user thing. Okay.
Taha,
So
can you just
let
close
us
your
proceed.
mic, please?
Please mute your mic.
Taha,
Something. Okay. So you are
Taha,
the
can
user
you mute your
training
mic?
market, not design market. Is that correct? Yep. Yep. I'll send you the link as well.
Sir, can you just remove him, please?
I'll have to see.
What is
Please,
this?
you
Getting
mute
right.
the mic, or I'll be forced to.
It is getting.
Sir, you are mute. We cannot able to hear you.
Is it fine? Is it fine now?
Yeah, it's fine now. It's fine.
Okay. So I said, see, we were speaking on this proof of work. You have to know that, because this is not, proof of work is nothing but it tells you or it gives you a good understanding of the protocol which is used in the blocks communicating with each other in a blockchain. We will use this and it this proof of work interacts with the blockchain class using, we will have it done using IPython. We will have this interact with the block using IPython. We will take a few good examples and see how does proof of work interact with a blockchain. Let's start off with a very trivial example of this proof of work. See, to understand that the hash of some integer, let's say x, multiplied by another integer y, must end in 0. So hash of x times y, you will get a big hash number. And for this simplified example, what we will do, let's take two variables, say x and y. Let's take the value of x as 5, y as 0, and find the hash of this when these two things are multiplied with each other. See, simple multiplication, if x is 5 and y is 0, it's 5 into 0 is 0. But we will see how does blockchain understand this when you use this hash function. Before I begin with this hash function, can somebody tell me what do you mean by hashing? Simple thing, very simple thing. Please tell me in very simple words as to what is hashing. What do you mean by hashing? Or what is this hashing in Python?
So it will take the reminder mod value and it will
Yeah,
store that value.
correct. Means in very simple words, input can be anything. It can be any input which even the user does not know, but the output will be a fixed output. It's in very simple words. See, like, if you multiply 5 by 0, what it is 5 times 0 is 0. We will see what does this hashing do when we want to when we want to find the hash of some integer multiplied by another integer. What happens? But all this using Python. So I shall say from hashlib, let me import SHA256. Then I take two variables. Let me say x equal to 5 and y equal to, let me say, 0. Now, if I want to multiply this, what I'll do, I'll say while SHA256 of, I take a formatted string, so I say f inverted commas, and I say x times y, I close the inverted comma, and this what I'll do, I shall encode it. I encode this, and did I miss out on anything? No, there is no bracket over here, there is the bracket here. Yeah, now it is fine. And then I say hex digest and of -1, and this I would say this is not equal to 0. Now what I'll do, since y I have taken it as 0 and this I have to make it conditional, I'll increment y by 1. So I say y plus equal to 1. Now when I print the output, see what I get. I say print, once again I take this f string and I say the solution is y equal to, I take a formatted placeholder, so I say y and an inverted comma, close this. So when we execute this, see what I get, 21. See how 5 times 0 is 0. But 5 by 21, when I take a hash function, it says 5 times 20, 5 times 0 is 21. That is why hashing is most preferred. In when you're developing any wonderful algorithm, anything in cryptography, anything, it is 0. See, the solution here, what I'm getting is y equal to 21. Since why am I getting 21? Since the produced hash ends with 0. Once again, please mark my words. I said the solution I'm getting here is y equal to 21 because the produced hash ends with 0. Don't believe me. Let's see. Let's ask Python and HA256 from the formatted string. Then this I take it as 5 times 21 and an inverted comma, double inverted comma, dot encode, and this I would say hex digest. Now let's see, does it end with 0? Wonderful, it ends with 0. That means the solution is y equal to, which I'm getting in as the output of 7, y is 21 is perfect, since the produced hash ends with 0. Now in Bitcoin, the proof of work algorithm has got a name. Can somebody tell me what is it called in Bitcoin? It is not called proof of work. It is called hash cash. HASHCASH, hash cash. And it's not too different from this basic example which we have taken. And it is the algorithm that miners race to solve in order to create a new block. And in general, the difficulty is determined by the number of zeros at the beginning of the string. And the miners are then rewarded for their solution by receiving a set number of bitcoins in a transaction. And the network is able to easily verify their solution, as what we did in this output of 8. Are you clear with the 7 and 8? Otherwise, once again, I shall repeat it for you, no problem. Anybody?
It is
Tell me
clear,
what-
sir.
Clear? Or does anybody want me to once again tell you in more simpler words? Fine, let me for my convenience tell you in more simpler words, because this is a very important thing or this proof of work. See, in very simple terms, proof of work algorithm means that that the system allows you to prove that your computer did some work. More technically, proof of work algorithms are consensus mechanism, and that is, if you can prove that the work was done, then you can show your proof to someone else who can easily verify that it is true. It's like this. Say you give an exam. And why is it that when you give your exam in your college or any college in India or anywhere, they take a signature of yours on the attendance sheet, so that if at all your paper is missing, you can claim that you had submitted or you had given your exam. So that becomes the proof of you having given exam. Similar way, this allows you to prove that the work was done. That is this proof of work. And you can show your proof to someone else who can easily verify that it is true. See, there are many variants of this proof of work algorithm, but what we will do, we will start off with a very simple example, which we have taken in this 7 and 8. So in this, what we will do, we will decide that the hash of some integer x multiplied by another integer y must end in 0. So I am taking two integers. I say that the hash of that integer multiplied by hash of some other integer should end in 0. So for this, what I'll do, let me take the value of x as 5 and y as 0. I find the solution. The solution is as what you see in 21. So it says that 5 times 0 is 21. So the solution is y is 21. Now in this, what happens, in order to confirm this, just to see that this hash what you have done is correct, it has to end with 0. So we have tried out what we wrote in 8 of mine, which says that it ends with 0. The produced hash ends with 0. So it's perfect. Now, in Bitcoin, we said that the proof of work algorithm has a name called hashcan. And it's not too different from any this thing. It's more or less similar to the one which we had seen. At this point, I would ask you people, do you know what do you mean by a jigsaw puzzle? You must have played this game of jigsaw puzzle. We will use that right away. What we will do, we will see on how do we implement this proof of work. So let's implement a similar algorithm as this for our blockchain. Our rule will be similar to this example what we have done. And for this, what we will do, we will find a number p that when hashed with the previous block solution, a hash with 4 leading zeros is produced. So continuing our example from what we have done all this time, let's add 2 new methods to our blockchain class: proof of work and valid hash for mining and validating hashes respectively. So what we will do, we will write a small, it will be more or less the same thing what we wrote in 6. I'll copy this thing, add something extra to this so that it adds, we are adding this proof of work and valid hash, which is added for mining and validating the hashes. So first 3 lines remain the same: import json from date time, import date time from hashlib, import sh256. Then I create the blockchain object, define, then self.chain, self pending transaction, it's fine. Then this is basically the genesis block. So we print create genesis block, self.new underscore block. Then we define, then what we do, I don't set out to create my last block. So I will knock this off from this. I'll straight away say I want to add a new block. I'll add a new block, then I'll, which is nothing but a self and previous hash, which I say none, and the block will contain index, timestamp, transactions, previous hash, and one other thing which you must have heard before: nonce. Can somebody tell me what is nonce? I have added one more thing which ideally any blockchain consists of. What do you mean by this nonce? What is a nonce?
So nonce is nothing but the numbers that the miners are trying to solve or figure out.
Yeah,
Which keeps changing.
it's not number, it's an arbitrary number. That the catchword is that it is an arbitrary number. I just add a nonce. I say let the nonce be null, nothing. I don't want any nonce over here, none. Then what I do, I get the hash of this block and add it to the block. So I say block hash, self dot hash, block of hash, I say block underscore a hash. Then what happens, what I need to reset the list of pending transaction. So I say self dot pending underscore transaction this, and then I add the block to the chain. So self dot chain dot append, which I append the block. So then I use the f string and I say created block is block of this index, and I return the block. And then what we do, we ensure that the dictionary is sorted, just because otherwise we will have inconsistent hashes. So we say block underscore string is json.dumps, block sort keys as true, encode, and we return sha256 or block string and hex digest. Now what we do, after this, I will add my last block. So I say define last underscore block of self, which I would say return self dot chain. The same thing what we wrote earlier of -1 if self dot chain else none. And after this, what I'll do, I will verify the proof of work as well as valid hash. So what I shall say, I shall add 2 more functions. I'll say defined proof of work of self, I would then say pass. Then lastly, I add defined valid hash of self, and then I say for this also pass. Let's execute this. Fine, no errors. So we have also added here a new field to our block structure called nonce, which means a nonsense string. Nonce is nothing but a nonsense string. Now think, what do you do? Please think of a nonce as, say, a once of random number, which will be used as an important source of randomness for our block. And for these nonsenses, nonsense, we'll generate a 64-bit hex random number using Python random module. Say I want you guys to generate for me, say, a 64-bit hex number, a random number, using Python random module. What will be the syntax? All of you are good in Python, please help me out. Once again, I want you to generate a 64-bit hex random number using Python's random module. What will be the syntax? Anybody? Please don't be silent. You wait for me, I'll wait for you. Boliye, tell me. I have to import random. Then I say format random dot get rand bits 64-bit, and then I would enclose X in double quote. That's all. I get a 64-bit random hex random number. Now, what till here is it fine? This is how you get a 64-bit hex random number. Random number. I don't know which number it is. I don't want to equate it also. Don't worry, whatever it can be. Till here, are we comfortable?
Yes, sir.
Okay. So what we will do now, we'll flesh out our two methods. That is this proof of work and valid hash. Starting with the latter. That is, we'll start off with this valid hash. This valid hash is pretty simple, and it needs to check if the hash of a block begins with a certain number of zeros. Let's say it begins with 4 zeros. So what I need to do when I define a valid block, I need to definitely say define valid block of block, make it conditional. I need to return block of hash, and I have to start it with 4 zeros. So I say starts with 0 0 0 0, 4 zeros. So this will also give me no error, nothing. This is a simple valid block I'm creating. Now what we can do, we will implement a simple say proof of work algorithm, which creates a new block and checks if it has a valid hash. So for this, what we need to do, I need to say define proof of work of the self, make it conditional. Then I say while true, new underscore block is nothing but self dot new underscore block, and then I would say if self dot valid underscore block of this new underscore block conditional, we break. And then what I need to do, I also need to append this new block. So I have to say self dot chain dot append this new block. I append the new block, and I say print found a new block, which I would say is nothing but new underscore block. So this code here, what we have done, we have created a new block. which contains a random nonce. And then then we hash the block to see if it is valid. And if it is valid, we return it. Else we repeat from 1, and this continues forever and ever and ever. Once again, this code what you written, that is 10, 11, and this one 12, what we have done, pretty self-explanatory. We have created a new block which contains a random nonce, and then we hash the block to see if it is valid. And if at all, if it is valid, we return it. Else what we do, we repeat from 1 forever and on and on and on. So what we will do, we will add these small little things what we have created to our existing blockchain, and let's see what we get as the output. So once again, I shall copy this 9 exactly as it is, because here we have done some corrections. So we copy this here, and here in this where do we add, see, we have told the last block, and then return self chain -1. uh, then we need to add this valid block. Where is this? Yes, here. Don't I, yeah, I need to, we will copy this after this last block. We shall add this here. No, this is a conditional statement, so it has two tab space. So after this, what I need to do, this is the valid block which we added. Then I need to add this proof of work. We will copy this proof of work after valid block, proof of work, while break here. Then this self has to be under while. Yeah, then even this print also a tab space. Then okay, now I don't need to do all this. I can knock it off. Let me see if I have missed out on something. Did we miss out on anything? No. Let me just execute this. Fine, no error. So you may copy this over here. This last two is exactly the same code. I've just added those two blocks over there. You can let me know after you have done, please. Let me know after you're done. In the meanwhile, what I'll do, some more lines of code. Let me just try it out. After that, when you say you're completed, I shall explain it to you. From blockchain import blockchain BC equal to blockchain. No module name blockchain. Okay. From blockchain. In fact, I'll have to save this as a blockchain. Okay. Have you completed till here?
Yes, sir, done.
Okay. Now, see, Do you know what do you have you done anytime when you were doing Java on socket programming? What is socket programming? See, when you learn Python, two very important things you'll have to learn is on what is socket and what is a pipeline. These are very, very important things because without this, Python does not rest. Before that, what we will do, we will okay, we will see how to do this socket programming on blockchain. We will see how to send and receive packets of information over the internet by building a usable networking application in the form of an say an online chat room, which will help us gain some kind of experience before we dive into this peer-to-peer networking. So what we will do, we will learn to send and receive packets of information over the internet by building a usable networking application in the form of an online chat room, which will help us gain some information before diving into this peer-to-peer networking. So before we do anything on this, you need to know the important network layers. Did you have this computer networking as a subject in any semester? Generally, it is in the third or fourth
Sir, we
semester.
had
Yeah. How many layers are there in TCP/IP network?
Yes,
7
sir,
layers.
we had it in one semester.
Okay. What does this protocol in the application layer do? And which are these protocols in the application layer? Tell me, which are the protocols which are in the application layer and what does it do?
Web applications, or it.
No. See, the protocols in the application layer are peer discovery, routing, and naming. And these protocols in this application layer are very close to the user because it's the bottommost layer and logically defines how user or these clients communicate with a service, such as this HTTP, hypertext transfer protocol. And then on top of this, which layer comes? On top of application layer, which is the layer which comes? Or you can say below application layer, however you view this. Which is the layer next to application layer?
Presentation layer.
No, it's transport layer. What does it do? What does the transport layer do?
Transports the packet to the network layer.
Little bit you'll have to polish your answers either. See, it's the transport layer encapsulates the application layer. That is the messages sent at the application layer. What it does, it breaks it up into segments and packets and establishes a connection between any two hosts across a network. Then which is this next layer next to this transport layer?
Network layer.
Yeah, what does it do?
It adds the IP address to the packets and then forwards them to the destination.
Yeah, that's right. See, it encapsulates this transport layer and it abstracts the notion of what is a network. That is the internet. Here, we know this internet is made up of many interconnected networks, and these networks require a protocol for routing data between them. And which is the next layer next to this network layer?
Session layer.
No, it's the link layer.
Link layer, so yeah.
And what does this do? What does the link layer do?
Linking of networks.
Formats the data. I think.
Links the devices.
No. See, it is responsible for transmission of raw, unstructured data over a physical medium, maybe such as an optical cable. Using this optical cable, see, it's responsible for transforming digital bits into pulses of light. If you consider this optical cable as an example. So these are some of the main layers. We won't see more on this because we are not doing networking. There is a library in Python called Asyncio. Have you heard of this library? It is written this way, the ASYNCIO. Asyncio. Have you heard of this? What is this Asyncio?
Nothing.
And what does this library do? Very important library in Python. That's why I said, if you remember the last semester when we were doing BDA, what did I say? Python has over 1,35,000 libraries, over 1,35,000 library. Humanly impossible to remember everything. But this essential libraries, you need to know what are they. Leave alone everything not required. What is essential, at least that you should know. See, this asyncio library in Python, this allows you to write asynchronous code in an easy to read way by giving you a ton of this helper functions. That is, this asyncio library helps you to write asynchronous code in an easy to read way by giving you tons and tons and tons of helper functions. And these allow you to separate your code into tasks which look like that they are running in parallel. So what we will do, since you are also being exposed to asyncio library for the first time, let's get a grasp of how this asyncio works by taking a look at one very simple program in asyncio. First, what we shall do, we shall install this asyncio. Few seconds. Yeah, it has installed asyncio. Let me restart the kernel. We'll write a very simple program, not even simple, extremely simple program on usage of this asyncio. Then see some important things about asyncio. See, it's not that we are deviating away from the task at hand. Asyncio is very important in blockchain for us. So what we will do, we will first import ncio yncio. We'll import asyncio and we will import time. Then what we will do, let me say, since it is used for asynchronous operations, I say async define greet of name and delay. Make this conditional. Then I say await asyncio dot sleep of delay, and again I'll use a formatted string. So I say print f string curly braces name, and we give an a colon, and I say I waited, and whatever the delay, say a formatted placeholder, so many seconds of delay, so many seconds before saying hello. Now what else is left? I need to close this inverted comma. Perfect. Now what I need to do, I need to define the main task. So what I shall do, I shall say async define main. This would be nothing but, I shall say task underscore one as syncio dot create underscore task, uh, create underscore task of greet. This I would say is, let me say t1, and let it wait for say 3 seconds. And the same thing I shall do it for task 2 and task 3 with little changes in that. So I copy this, I say this is task 2. So instead of greet t1, I say greet t2, and instead of 3, let me make it wait for just 2 seconds. So again I copy this task 3 syncio create task, instead of t1 t3, and this also I shall say just 2 seconds. Now I need to start the time, because we have specified time all over. I say start time is time dot time, and then I say print um, 0.00 seconds, which is nothing but my program start and my inverted commas. Now I need to, what do we do to close this? So I say await task underscore 1, await task underscore 2, await task underscore 3. Then what we need to do, we need to even print it out. So I say print again an f string. I say and um, time dot time minus start time colon, let it have two places after decimal, so dot 2f curly braces seconds inverted sorry, a colon, we say program end, and I need to put a double inverted comma here for it to end. So and then finally we say asyncio dot run of this main. That's all. Let's see if you have missed out anything. No. As of now, nothing. Okay, it tells me asyncio dot run cannot be called from a running event loop. Okay, async dot run of main. Mm, 1 second. Let me just make this as a comment. Fine. Basically, this is to run the application, not a problem. Don't worry, not an issue. You save this as asyncio and call this, make it execute it. You will have 3 tasks being performed. That's all. Now you might be thinking, okay, after you completed this, I shall tell you. Let me know after you're done this, please.
Yes, sir, done.
Okay, fine. What about others? Please complete it. Okay.
Done, sir.
See, the most important thing of, tell me one thing. Say you create a blockchain, a simple blockchain or whatever kind of a blockchain. Now, if your blockchain is in isolation, what is the use of the blockchain? Definitely, your blockchain has to be connected to other clients over the network. Otherwise, your blockchain is totally useless. So what we will do, we are going to start with something similar, and what we will do, we will see how do we build a chat server for this, and which will allow many of these connected clients to chat with each other at once. So with your available knowledge, can you tell me one thing, which is the you can say, which is the most robust chat protocol which is in use since the early days till today? Which is the most robust chat protocol which is in use in the industry as on today, and it has been in use for quite a long time? Which is it?
And WhatsApp, sir.
No, not WhatsApp, sir. It is since 90s. It is IRC, Internet Relay Chat. It's a very robust chat protocol from the early internet, which allowed people all over the world to chat in chat room. IRC since 90s it is there. Very in somewhere in 90s it started. Since then it's a wonderful. You can also use this IRC, but I don't think anybody uses it as on today, with this WhatsApp and the other things coming into picture, which makes it much more simpler. But implementing this IRC protocol is pretty tall order, and I would say because this is by learning by doing. You're going to ignore all the prior work, and in the name of time and simplicity, just focus on a minimal example to help get the gist of writing some asynchronous TCP server client application in Python. See, modern web applications which are there as on today are really scalable and concurrent. So it is very important to understand how asynchronous code is written to avoid any of this common pitfalls. So in order to accomplish our goal as of now, where we are building a small little chat server, we are going to be building a chat server using TCP sockets. So what does and definitely I'll get hold of my good friend of Python. and Python makes it easy to work with them. And in fact, this asyncio module provides a lot of functionality out of the box. So what we will do, we will begin with as simple as it gets, which is nothing but a plain echo server that simply sends back any message which you send to it. It is called an echo server. If you send a message and the same thing comes back, it is an echo. Your sound is echoing. So we will try building a small little chat server with this, using this asyncio library of Python, where we will be using a plain echo server. So for which what I need to, all these things are very, very important. It is not that we are having some class in Python. No. See, like I said, if you have create a blockchain and your blockchain is an isolation, what is the use? It has to communicate with the other clients all over the network, and which is the network? Internet. So it has to communicate with that, for which you need a chat server. It chats with all other blocks. How do you write that? We are creating a very, very simple chat server for that. So for this, what we will do, I have to import asyncio. So I say import asyncio, and then this is little tricky. Even I get confused at times with this. Just then async, I would say defined handle underscore connection of reader and writer. We shall make this conditional. Then we say writer dot write of this hello, let me say new user. We shall say type something. Then let me say some dots, and in the next line we shall say this dot encode. That's it. Then what I would say, I wanted to read in some data. So I say data, which I take as a variable. I say data is await reader dot read until b, and I take it in the next line slash n. Now, after I read the data, I want the writer to take over. No, there is something missing here. One more inverted comma. Yeah. Now I want the writer to take over after this. So I say writer dot write. I would say, now since you read the data, writer has to say it has received the data. So I say you sent, and this would be dot encode plus data, and then we will say await writer dot drain. So now what we need to do, after we have written and read the data, let's close up the connection and clean up. So we have to close up this connection and clean it up, for which I shall say writer dot close, and I say await writer dot wait underscore closed. Now this is being basically I have declared what is my writer, what is my reader, all these things. Now let me define the main function. So I say async define main conditional. Then we say server is nothing but my await syncio asyncio dot start server with my handle, which I say handle of connection, and this let me take it as 0.0.0.0 0.0.0, and listen to port 8888, and I need it to get asynchronous with the server. So I say async with a server, which I'll make it. Then I say await server dot serve underscore forever. So it will serve the wait for the server. Now then what I need to do, let me just execute this. Perfect, no error. You can run this and see, and it will be what you will get. You will get you run this and you send it some information to get a sense of the expectation. You can do one thing. You can open up two terminals and put them side by side. Say in the first terminal, you say Python, and you call this as, say, my server. You say Python my server.py, and the second terminal, connect to the server. You say using this NC connection. You say NC 127.0.0.1 and port 8888. Or if you're using Windows, you use Telnet. You say Telnet 127.0.0.1 8888. See what output you're getting. It's an echo server. The same message will bounce back to you. Okay, if you may please write this. Good that we got no errors. I was expecting that it would throw some error. Oh, there's a spelling mistake here. Connection. That will not make any difference. No, forever. There's double E has come over here. Some small little spelling mistakes. Done. Have you completed this? And how do you execute it on Windows? You just say, since you're using Window machine, you say go to the terminal, say telnet 127.0.0.1 and 8888, 4 times 8. You executed this. And then it'll ask you to type something. You'll get this message running. Hello, new user, type something. Type in some message. You'll get back the same message because it's an echo server. Have you completed it?
1 second, sir.
Yeah.
Yes, sir.
Okay. Now, see, we are bang on target to build the chat server. So we will accomplish the chat server by first establishing a simple, very simple communication protocol for chatting on the server. Now, when a user connects, they should be prompted for their nickname. And we will say when a user connects, their arrival should be broadcast to every connected user except themselves. That is, when the user connects, you should tell everybody that the person has joined except the person who has joined. Now, if a user sends a message, what should happen? Their message has to be broadcast to every connected user except themselves. And if a user sends a message, they should see a list of all connected users. And what else? Now we say a user sends a message as quit, they should be disconnected, and message saying whatever the nickname has quit should be broadcast to all connected users. These are some of the guiding factors when you get connected to an existing blockchain. When you quit, it should say this whatever your nickname has quit. So what we will do, we will create a connection pool class to manage the pool of connected clients and house the logic for the protocol mentioned. So to do this, what we should do, we will create some placeholders for the methods. So what we will do, we'll add some say annotation to explain what each method should do. So by this time you should be knowing how do we start off. I have to start off by importing this asyncio. So I say import asyncio. Then I create a connection pool. Why are we creating a connection pool? To manage the pool of connected clients and house the logic for the protocol mentioned. So we say class of connection pool, and then I define the genesis block. I say define init of self conditional. I say self dot connection underscore pool. This we set it. Fine. Till here is should not be a problem. Now first is when the client gets connected, we will send him a see. Currently, I am not writing the full program. I am telling you what will be the backbone of the program. After this, what I'll do, I have to say define. Let me send a welcome message to the person or the client who has got connected. So I'll say define and send welcome message to the self and writer. We will make this conditional. Now then whatever the welcome message I write over here, and lastly I say pass. After this, what I need to do, when the user gets connected, I have to broadcast to the entire group except the user that this person has got connected. So for that, what we need to do, we need to define broadcast of the self and writer and message. Make this conditional, and whatever the general message I send to the whole of the pool that this person has got connected, and I last end it with pass. Now this is no sorry, after you send the welcome message, you broadcast to the group as to what you need to do. Then you say about the user having joined. So then after this you say a particular user has joined. Then we will say the user whenever the user quits, which user has quit. So I say define broadcast underscore user underscore join of self and writer. Make it conditional. Some messages we say, and then lastly I say pass. And after this, I need to even take care of when a user quits the blockchain. So I say define. I need to broadcast this. I say define broadcast underscore user underscore quit of self writer. Make this conditional. Whatever message that the user has, whichever user has quit, and pass. And now what I need to take care, now I've taken till now we have taken care of the genesis block. Thereafter we have sent a welcome message, then we have told what is this blockchain going to do, and then we have invited a user. We have even told everybody that this whoever this user has joined, and we have even told when a user quits. Now if there is a user's chat message that has to be broadcast to everybody except the user themselves. So once again, I say define broadcast underscore new underscore message of this self and writer and message. We will make this conditional. Then whatever message is being transmitted, I say pass. And now I have to list after this, what else is left? I have to list all the users also who is there in the blockchain. So for which, once again, I'll have to define a function. Let us call it list underscore users of self and writer. And whatever, list all the users and then say pass. And now these users who are there, I have to add these users to the pool of the users. It is not only list, I have to add these users also to the pool of users. So I have to define another function. I say define add new user to pool of self and writer, and whatever the users you have added to the pool, and then I pass. Now, when you're adding a user, you have to even, there should be a provision for removing a user from the pool. So for which, what we will do, we will say define remove user from pool of self and writer. And we will remove the user from the pool. And then I would say, I won't say pass, I'll say self dot connection underscore pool dot remove this writer, and I'll write it that the person has been removed from the pool. Now what else is left? Now I have to define a handle for all these things. Basically, I have to say what is the message which is being displayed, what is the message which is being written, all these things I have to define a handle for this. So what I shall do, I shall say async define handle underscore connection of reader and writer conditional, and then we would say writer dot write. Let me say hello new user, type something. We will ask the user to type something, put it in new line, inverted comma, and this we will encode. Okay, after this, what we do, we have to wait for the reader. Since you return the data, you have to wait for the reader to read the data. And once you wait for the reader to read the data, after that the writer writes the data. So I say data equal to await reader dot read until, same thing like what we did earlier, b/n. Next line. Now the writer takes over from here. I say writer dot write. The writer would say you have sent it. You sent, and this would be encode. This would be encode plus the data. And the writer has to your writer drains down this data or puts it into his throat after having written the data. So writer await writer dot drain. Now after all this you have done, you have to close the connection and clean it up. So to close the connection and clean up, what do? You say writer dot close, and then you say await writer dot wait underscore closed. And now what we need to do, we need to you once again use this async module and wait for it to sync with the server of whatever you have done. So what we shall do, I shall say async define main conditional. I say server is nothing but my await asyncio dot start underscore server handle underscore connection, and once again this one 0.0.0.0, and for the port to which port listens, it is 8888. I have to asynchronize with this with the server, so I say async with server, and I say await server dot serve underscore uh, forever. And now for this I need to make a connection pool of this whole lot of thing, so I say connection underscore pool is connection pool. That's all. Now your program is complete. This is the complete backbone of how do you write a program, so or how do you make your blockchain communicate with all other blocks which are existent. So you have to write something, otherwise for your blockchain which you have created in isolation is of just no use unless it communicates with all other blockchains, all other peers on the network. And network is internet. You will not be able to execute this because there are some a lot of gaps which are left in between. We will write after this a complete program, to broadcast, say, let's say, a welcome message, where you create a blockchain, put it on the internet, and you want your blockchain when it interacts with everybody else, it should communicate a welcome message. So after seeing till here, right from the first day which we have done till now, how many of you amongst you, because you are the only few people in your class, guys in your class who are interested in blockchain, how many of you interested in working on the blockchain project? It's a wonderful live project. Aim is we have to get it up and running for the. Tell me, anybody interested? It's good. Finally, nobody.
Sounds difficult, sir.
That's the see. Nobody on earth is born learning blockchain. You imbibe it over a period of time. But the best way to learn, the best and the best way to learn any technology is work on the technology and learn it. You learn it faster. You learn how to handle this in a very fast way. But unlike working with maybe any MNC or anything, you will have nobody in your team. You will be all alone. At the max, I will be in your team. Nobody else will be there. And definite timeline. Definitely, we have to do it in a definite timeline. Few people are volunteered to join me. They are from Sultanate of Oman. They are brainy guys who have done the doctorate in this, but really they don't know what these things are. For them, it's the first time they'll be working, but they are very upbeat in joining me for this. I've told them a couple of days, I'll get back to you. That is why I'm hurrying it up even with you guys, telling you guys to submit your solution by tomorrow evening because we don't have time. And definitely this has to be done in a definite time period. For that reason only, I've involved 3-4 different colleges in India, colleges and some universities in India, so that you get to work on a cross-country basis with some students studying in other colleges, other universities. Don't worry, we will
give us about 2 or 3 days time. We will work out in the something.
Okay, no problem. Because see, when you work with students of other university, you will know what is the level, where is that you stand, how much you know, how much you don't know, or what is it, what is the level of your understanding. But definitely, you would be able to do really good in this. And And if I would suggest that somebody to join, at least one or two to join for the minimum, at least one, two of you to join for this. If not this, no problem, it's fine. If you find it really tough, like what Saida says, definitely fine, you join for the other one where we are doing this thing on exclusively on predictive analytics. What is the problem? I'll tell you after tomorrow 6 o'clock. That's why I've asked you to, all those two, three of you who attended the session at 12 in the afternoon today, to mail me some kind of a solution by 6 in the evening. So if at all you're interested, please get in touch with them. And as it is, I've told them to convey it to everybody. Please get in touch with them. See what is that you need to mail it to me by 6 tomorrow. Because I will be sending the link of the meeting only to those guys who mail me the solution by 6, nobody else. And definitely we will meet up between 8 and 9 tomorrow, because from I think 9:15 or 9:20 for 2-3 hours in the night, I've got a session with very interested guys based out of London. Some more interested students like you, not students, they're working professionals. So some more chaps who are much more interested, but that's actually for a structured course. Okay, this has got nothing. So this is what we do. Once again, there's a small spelling mistake. CNNECTION. Yeah. So this we will write a complete program on basically creating a simple welcome message. For this, what you need to do, I'll write it again. Otherwise, I'll miss out on certain things. Definitely, I have to import asyncio. Then before this, I have to install TextWrap on my system. So I say pip install TextWrap. So let me try it with conda install if it works. Conda install TextWrap. It's not able to find that package. No, it's not able to get it. No problem. Let's restart the kernel. Perfect. What we will do, we need to import uh, asyncio, and then from TextWrap, I need to import ddent. Let me try this. Yeah, no errors. So fine, it's able to import this ddent. These are some very important things. This we are writing a proper program for it to display a welcome message, so that when your blockchain gets hooked on to other blockchains on the internet, your blockchain is able to send a welcome message. So after this, what I shall continue with this itself. So then I need to say my class connection pool, make it conditional. I say define underscore underscore init underscore self, and then I say self dot connection underscore pool. This is set, and till here let me just try it. Should not be a problem. Great. So we continue with this. The next function is I need to send a welcome message. So I say define send welcome message of self and writer. Make this conditional, and I say my message is didn't. I use a formatted string, triple the thing, and I then give triple equal to, and then I say welcome in a curly braces. I say writer dot nickname. And what do we say? Did I miss out anything? Why this red colored bracket? Didn't formatted string. I give an exclamation here. Then I say there are length of self dot connection underscore uh, connection underscore pool minus one curly braces users here besides you. And then what do we say? Then I say help, and then we say hyphen type any anything to chat, and then we once again say hash slash list will list all the connected users, and then we also say quit will disconnect you, and then once again I close it with this triple equal to, and then three double inverted commas, close it. Now I need to say call my writer. I say my writer dot write of using this f string. I say message slash n dot encode. Okay, now after this will at least send this welcome message. Now I have to broadcast this to all users on the network. So I have to say define uh, broadcast of self um, writer message. We make this conditional, and then we say for user in self dot connection underscore pool. We make this conditional, and what we say if user not equal to um, if user not equal to writer. So if it is not equal to writer, then you don't need to broadcast to the user sending the message. So what we shall do, we shall just say user dot write again the f string of this message slash n inverted comma inverted comma dot encode and this should help me broadcast the message. Let's just see. Fine, perfect, no errors. Now what I need to do, I need to define the user who joins also should get this message. So for this I need to say define broadcast underscore user underscore join of self writer, and then I make this conditional. I say self dot broadcast of writer, and I use the f string. I say my writer dot nickname. Um I would say just joined inverted comma close my bracket. Perfect. Now this would help me broadcast this message to even the user who has just joined. Now there might be cases when user leaves the session, so we have to tell all the users in the network that somebody has left the session. So I would say define broadcast uh, user quit of self and writer. Make this conditional. We say self dot broadcast of writer, and then an f string. We say writer dot nickname. Close this, and we will say he has just quit inverted comma and close. So this should wonderful, no errors till now. So now what else is left? I have to broadcast a new message. So we define another function. We say define broadcast new message of self, writer, and message. Make this conditional. We say self dot broadcast of writer and an f string. We say no, there is square bracket, curly braces of writer dot nickname. And then here I need to put a formatted placeholder. We will say message, and after this inverted commas. That's it. So this will broadcast the new message. As earlier, if you remember, we have to even list the users who are there on the network. So I said define list underscore users of self and writer. And then here I need to say message is equal to, I will say triple equal to in the next line slash n. And I would also have to increment the message to the connected users. So I say message plus equal to currently connected users. Then what I need to do now, if a user is in the pool, what do we do? So let me take care of this. So for user in self dot connection underscore pool, we'll say uh, if user assign this as the say the writer conditional, we say message which will be incremented with this f string, we say slash n minus user dot nickname, and I would say this is you, and with a inverted commas. Now this should take care of this. Yes. Now since uh, okay. Since I use the if, close it with else. I say message plus equal to the f string slash n minus user dot nickname, and I close my double inverted commas here. And I also need to increment my message. So how do I increment the message? I say message plus equal to slash and next line equal to equal to equal to. Then I write this thing what we have done. So I say writer dot write. We use the f string of message slash n inverted comma dot encode. And then what we know, I have to then I need to even take care of adding a user or removing a. Till here let's just execute and see. Great, no errors, absolutely no error. So I have to add user and even remove user from the pool. Have you completed it till here?
1 minute, sir.
Yeah. Don't you guys feel this is very simple Python what we are writing? What do you say, Saida? Isn't it very simple Python what we are writing, or is anything complicated in this?
No, sir, not complicated.
Yeah, then it's fine.
Completed, sir.
Completed. Okay. See, we need to know what is left for us. We need to add users to the pool. That is the complete chain where we are having users. We have to remove users. All these things we need to do. This I'll suggest we shall do it in the next session. Okay, this work what we have done, let's save it and keep. And I shall request you guys, if since your HOD is also there, sir, can we have a class even maybe next Wednesday sometime in the evening, say sometime around 7:30 or so? Will it be possible? 1 hour. Bari sir, are you there? No. Okay, I'll have a word with him if we can. Are you guys free on Wednesday?
Yes, sir, we are free. We don't have any classes till 30th.
Okay, then it's fine. Let me just let's take your attendance. Let's do justice with this. Complete your attendance part of it.
Sir, by what time should we be uploading our mini project, sir?
It was yesterday was the last date. You can do one thing. Give it to me by evening today. That is before morning 6 o'clock tomorrow. You mail it to me.
Okay, sir. Thank you.
Sir, we should send you the whole project with the code, or just the report part is
No,
enough?
no. The project with the code. Okay, please mark your attendance. 733,056. 733,095.
Present, sir. 56.
56%. 77733,002. 7773021. 7773026. 7773035. 7773053. 7733. Okay, 7773056. 7773067. 7773084. 7773086. 7737004.
Present, sir.
7737017. 7737027. 7737030. 7737033. 7737044. 777 733,007.
Sir.
733,008. 733,015. 733,018. 733,020. 733,022. 733,027. 733,032. 733,034. 733,041. 733,045. 733,061. 733,070. 733,071. 733,072. 733,080. 733,081. 733,097. 733,108. 733,112. 733,114. 733,301. 733,303. 733,07. Taha Abdul Razak.
Sir, Taha present, sir.
Okay. Afreen. Mohammad Ahmad. Mirza Asif. Mohammad Azharuddin. Sayyid Alauddin Bukhari. Zakaria Iqbal. Mohammad Jawad. Mohammad Shoaib Khan. Syed Nihal Hussain Madani. Mohammad MOHD. Asma Namira. Rehma. Syed Abdul Rab. Sajjad.
Sajjad is present, sir.
Sheikh Sadullah Sharif. Syed, Tuba, Abu Ansari, Abdul Qadir Khan Khalid, Aslam Khan, Mohammad Samir, Mohammad Rafiuddin. Perfect. Now it's done. What we can do? 733032 says he's present. 733032. Where is he gone? Two. Where are you, friend? 733032.
Sir, screen is.
Sorry?
Yes, your screen is off. We
No
can't see you.
problem. Not good. Don't worry. Yeah, 733032. I marked you. Don't worry. Okay. Fine. I marked everybody. Thank you. We will catch up the next time when we meet. That is the next. We will see. Let me speak to your HOD. We'll, if possible, we'll have it on Wednesday. Otherwise, we meet on Friday and Saturday. Thank you. Have a nice weekend.
Thank you, sir.